Hi students, in this video we will learn cellular networks, and it is a 2G network voice connections to the telephone network. And the term cellular refers to the fact that the region covered by a cellular network, and this region is partitioned into a number of geographical coverage areas, and these small areas are known as cells. And here in this figure we can see a hexagonal shape which represents a cell, and a cell consists of a base station and multiple mobile stations, and these mobile stations are controlled by the base station, and each base station is controlled. Each cell is having a single base station, and it transmits the signals to the receivers within the cell. And similar to that, multiple cells will be connected to a single MSC, and MSC is known as mobile switching center. Then the mobile switching center is connected to the public telephone network, or this is also known as the gateway. The mobile stations within one cell can communicate with other stationary units in another cell. So a cellular telephony is designed to provide communication between two mobile stations, or between a mobile unit and a stationary unit. The service provider must be able to locate and track a caller, assign the channel to the call, and transfer the channel from BS to BS as the caller moves out of range. And the cellular service area divided into small areas are called cells. And each cell contains an antenna, and it is controlled by the base station. And each base station is powered by a alternating current or a solar current. And each base station in turn controlled by a switching office called Mobile Switching Center, MSC. And this MSC is coordinating the communication between base station and the telephone central office. So MSC is controlled by the telephone station. And the cell size is not fixed, and it can be increased or decreased depending upon the population in that area. That is, the number of mobile stations within the cell are limited, and if the population is high, the cell size will be low. High density areas require small cell size. The coverage area of the cells depends on many factors that include the transmitting power of the BTS, means base station, and the transmitting power of the user devices, and buildings in the cell or obstacles in the cell, and the height of the base station antennas, etc. And the cell phones are working on the basis of a principle called frequency reuse principle. In this figure we can see that the green area, each of these hexagon represents a single cell, and there will be one antenna for each cell, and then antennas of each of the cell is assigned with different frequency values, and the neighboring cells cannot use the same frequencies because it may create interference for the uses located near the cell boundaries. If the antenna of this particular cell is using a frequency, then another cell which is sharing its boundary cannot use the same frequency. This frequency and this frequency and this frequency and this frequency will be different frequencies. But the frequency set are limited, we have to reuse the frequencies again. So the same frequency sets are repeated, but never two neighbors will share the same frequencies. So this yellow area with four different frequencies, the same set of frequencies will be shared, repeated in the green area, same set of frequencies will be repeated in the pink area, but the neighbors will never share the same frequency ranges in order to eliminate the interference. So frequency reuse pattern is a configuration of n cells. Here it is a reusability pattern of 4 and here it is a reusability pattern of 7. So 7 neighboring cells will have different frequencies and another set of 7 cells will be using the same set of frequencies repeatedly. But neighbors will never share the common frequencies. So n being used as a neighboring factor. In this case, here n is equal to 4 and here n is equal to 7. And there are different patterns. The numbers in the cells defines the pattern. And the cells with the same number in the pattern can use the same frequency. That is, here it is using a 7 and in green also there will be one 7, but these 7 all the cells having the same number is having the same frequency, but they will never come as neighbors. This figure it is more clear. 2 is a frequency, 2 is a frequency in green area and yellow area, but these two will never come as neighbors, though they are having the same frequency range. And here the reuse factor is 4. So the maximum number of frequencies are 4 different frequencies. Here it is 7. Now let us see how these cell phones are transmitting the data when a connection is placed, when a call is placed. To place a call from the mobile station, the caller enters a 10-digit telephone number and press the send button. So the mobile station is want to place a call and it is entering the 10-digit number and they press the send button. Then the signal request will be sent to the nearest base station. And the base station relays this data to MSC. MSC is the mobile switching center. And if the called party is available, the connection is made and the result is relayed back to the MSC. So the remaining part is done by the public switched network. The MSC will transmit this information or send this information to PSTN, public switched telephone network. And this public switched network is searching for the receiver of the call. Then if it is available, then the connection is made by the PSTN, public switching telephone network, and this information is relayed back to the MSC, and MSC will assign a channel for the call and the connection is established. And what is happening at the receiving side? When a mobile station is placed a call, then up to here the transmission is happening. Then the duty of the PSTN is to identify the receiver. So the telephone central office sends the telephone number to the MSC and MSC searches the location of the mobile station by sending a query signal to each cell. So this MSC will be connected to some more cells and Multiple cells will be controlled by a single MSC. And the MSC searches for the receiver by sending query signals to each cell under its control. This is called paging. The paging is a procedure the network uses to find a subscriber's location before the actual call is established. Paging is used to alert the mobile station to an incoming call. Then various versions of cellular phone are 1G, 2G, 3G, 4G and 5G. 1G was designed for voice communication using analog signals. That was the first version. And for 2G, mobile voice communication is possible and the voice is in the digitized mode. And in 3G, a combination of technologies that provide both digital and voice communication. And it provides portable devices as well. And 4G, it is a high network capacity and high data rate and smooth hands-off. Hands-off means we are aware of this terminology. That is when a mobile station is moving from the range of one BSS to another BSS, it is known as the hands-off. So the smooth hands-off means when a mobile station moves out of the range of one BSS and entering into another BSS range, then there won't be any fluctuation in the communication. So it is possible by smooth hands-off across heterogeneous network. And global roaming across multiple networks and high quality multimedia support and support for IPv. All these are the latest version 4G is provided with. And currently cellular telephony is in the range of in the generation of 5G, and 5G is the generation which is currently under development.